Thank you. So Palantir's work with the government, our origins are generally better known, but actually at this point, 70% of what we do is commercial, working with institutions like Chrysler, Morgan Stanley, AT&T, et cetera. And so I've been at Palantir for 14 years, and I want to reflect on that joint experience between government and commercial to think about a way in which we can have a unique approach to competitiveness in this century. You may have heard that data is the new oil. Well, I would like to have a heterodox perspective that actually, as a practitioner, someone who's been doing this for 15 years, to me it feels more like data is the new snake oil. And I think, though, there's some silver lining here. Herein lies an opportunity that defines American competitiveness in this century, which is not just about AI or big data or technology per se, but how do you operationalize these things, not just to compete, but to win? So I hope to be productively contrarian and a little provocative throughout the talk. I want to start with the frame-setting analogy from history. Gorbachev and Deng were both leading their countries at a time that it was very clear that communism was not working. They were falling behind at a faster rate. And I think actually this analogy is pretty instructive in terms of thinking about why do most of these big transformational projects fail, AI, digital, or otherwise. They took very different approaches to dealing with this problem. Gorbachev essentially flipped the bit overnight. And it was an unmitigated disaster that really those countries are still paying for today. Deng took a very different approach, one that is often referred to as feeling the stones as you cross the river. One that really, at its core, is honoring the pathing. Sometimes pejoratively in the West, we call it gradualism, but I think that kind of obfuscates a more profound lesson underneath. And for me, that is that while things were quite bad sitting in Deng's shoes, like, yes, we aspire to be substantially better than we are today, it was also very clear that things could get worse. And so the pathing that you took became really important. There was a journey involved, and that journey was about honoring what made you strong today, what made you unique in the world, and iterating and evolving around that. And I think ultimately that worked. So if we think about this in the context of AI or big data, national security, there is a future we want to get to. It's on the other side of that river. It's very tempting to try to just flip the bit and get there. But I think in doing so, you give up everything that makes you unique today, or at least you put that at risk, instead of thinking very hard about how do we build that journey around what makes us strong. So in the defense context, we have just tremendous operational prowess in the world. We should be building around that, and I think we are. In the U.S. commercial context, we need to be seeking increasing differentiation along the way throughout this journey. We need to invest in things that make us more special, that make us more unique every single day. Because the two things these have in common, the advice for defense and commercial, is that put very succinctly, competition is for losers. We're not trying to compete, we're trying to win. Right? And if you're going to win, you have to be more differentiated, more special, more unique. So let's look at this in a specific example. Why is this journey hard? Let's build some intuition for that. And let's do that by essentially asking the wrong question. That's what makes the journey hard. And a classic example of how AI is applied to something like predictive maintenance. It is a problem that's actually kind of well suited for AI. Can you predict which part is going to break? Let's take an example of the wheel on a locomotive. A wheel is a very expensive part, and obviously if the wheel breaks, there is no locomotion. And so it turns out, yes, you can use AI to predict that this wheel is 50 times more likely to break than a random wheel, which really means that you went from a 0.1% chance of the wheel breaking to a 5% chance of the wheel breaking. You are not going to replace 20 wheels so that you can prevent one of them from breaking. So that actually, this is snake oil. This is a completely uneconomic insight that you can do nothing about. And so when you're in this phase of the journey, you realize I'm asking the wrong question. The question is not which part is going to break. It is actually, what am I good at? I do maintenance. I do 2 hours of maintenance every night. What is the optimal set of things that I should be doing in those 2 hours that create economic value, that create increasing differentiation? And that's a much harder question, by the way. It's not as simple. It's not as well suited to a closed system that you can just solve it. It's something that's what makes it a journey. You have to earn the right to get better and better and better at that. But in doing so, you're winning. This is how you compete and win. This is probably the optimal thing this company could do to reduce their maintenance costs and have a lower cost of service and own the market. If you follow this sort of thinking to its logical conclusion, what you realize is that actually this journey is about starting with your humans and wrapping the technology around them. You're actually building an Iron Man suit for your people. And it's building that Iron Man suit that is the journey. And so in 15 years of doing this, I've seen all these patterns emerge of kind of progress and maturity, roadblocks, and the pathing sort of involved. And I've kind of distilled it into these 5 levels of enterprise autonomy, intentionally set up to mirror the 5 levels of autonomous self-driving cars. The specifics of the levels are not quite important, but I think what's actually interesting is you can't skip a step. Everyone wants to start with level 5. Everyone wants to get to the promised land. But actually in doing so, you find you're just right back at the beginning. You're at level 1, and you've made really no progress. And I can illustrate this through an example of work in defense broadly, an important project in the national security community that is seeking to transform how we operate through AI. And you can divide this journey into 3 distinct phases. The first was all about algorithms. Motivated by the obvious success of ImageNet and the fact that these algorithms actually work, we should be seeking to apply these classifiers and ML talent to some of our national security hard problems. In doing so, actually, the algorithms only ended up being 50% accurate. Okay, so then this is where the snake oil comes in. So the next part is something like wave 2. You know, the algorithms are fine and they work, but what's missing is data. If we had really unique data for our context, we could get this to be substantially more performant. The whole problem is then framed around, if we get to 90% accuracy, we win. Having invested a huge amount of money in generating this really unique data, they got to past 90% accuracy. But it became very clear that even if they got to 100% accuracy, you would not win. And the reason you would not win is as soon as you got this into the hands of users, of warfighters, they said, this confers no decision advantage to me. This is telling me things I already knew. There is no mission impact or economic value from this technology, which works. Right? So you realize you took the snake oil path yet again. Wave 3, the third phase of this, was about integration. Actually, yes, level 5 self-driving car, if you will, is still the end goal. But let's not be so condescending about the achievements of level 3. Lane change assist and automated self-parking are pretty unique and valuable things. And in the context of warfighting, the equivalent of those things confer decision advantage and increase lethality to the force. Let's earn that capability. Every step in that river that we take where we get those level 3 capabilities actually positions us better to get closer to level 5. And in doing so, we're providing value today, we're building around our strengths, and we're winning. So you could ask the question, how did we get here? And I think the reason is that when we think about algorithms, one of the things we don't think about often enough is they are complete commodities. In the context of competitiveness, I mean commodities. They are freely available in the public domain, all the interesting algorithms that you would possibly think about, and they have been so for more than 20 years. Some of these algorithms you will find on microfiche back in libraries when I was growing up. That's how old they are. So how could you have creative or a sustained competitive advantage around something that's that freely available and that old? And so then the next part is, of course, well, the data is the oil, because we're going to use unique data to train these algorithms to be specifically valuable in our context. And that's true. The data will make the algorithms more valuable, the classifiers more specifically useful in this context. But more useful at what? Did you ask the right question? Do we frame the question, are we applying ourselves at solving things that have economic value, that have mission impact, that will confer decisive decision advantage to those who are using it, and provide long-term increased differentiation that enable us to win? And I think that's actually the strength of the American system. That's a place that we can be dominant, which is not just in the context of R&D, but the full integration of the R&D through the application and the feedback cycle in between. How do we operationalize these technologies to win? Thank you.